Previously on Stat 201.
Hey Brian, what's up?
Hey Adam.
Oh, what's this?
Adam, what are you doing? Adam!
No!
Hey everyone, Jason here. We've tried to find someone to do the Kahoot. You know what though? We could just try and bring him back. I happen to have this. So we'll see what happens.
Hey guys! I'm back. Jason already saved me. Jason is the man who went and stole the Infinity Gauntlet. So, so Jason getting some love there for the blazer right there. So glad to see everyone. We got everyone in here, and I'm glad you liked it. Jason and I had fun with that. So, Jason, I know it's just he'll do anything. He is gonna save us all. He's gonna help us all with the test, get us all ready. So we were worried. Oh no, Jason's not dead. Oh no, you're right. No spoilers. Exactly. So we are good to go. We are back in. I am back alive, back around, worth the wait. Awesome. Gabe, so good to have you. And we're glad you liked that. Worth the wait right here. Plot holes? There's no plot holes. No plot holes. Nothing going on. Just a 15-minute snapping. Just snapped away, snapped right back. So it was Adam who snapped me away. So should never have left that laying around my office. So it's literally my office. Anyways, we are waiting for people to join the Kahoot right now. So if you didn't know, your instructors probably sent you out the link. I never make the Kahoot thing public. We only have 27 people right now. Does everyone know? Remember, don't put it in the chat where to go for the Kahoot. Adam's a great guy. So don't put in the chat where to go for the Kahoot. We got about 100 people watching, but go to the Kahoot. If you know where to go to get the link for the Kahoot, don't put it in the chat though, because so we can't put the code in the chat, or we could get Kahoot crashed. And so don't put the code in the chat. Would you guys like me to send out an email with the code in it? There should be. Got dual laptops here. It should be. Let me send it out. I will send out. So give me one moment here. We'll send out the code in the. Let me get the code. Last we crash. So, that's what we gotta do right here. One moment, we'll get everyone up and going right here. We'll be starting the Kahoot soon. So we're just kind of in the interim right now, getting Kahoot ready. So let's do this right here. Kahoot code. Okay, we are sending this out to you guys here. Make sure that's the right one. Should be right. Okay, so there is it there. We will all be in A and B. And so let's go over here. Let's send out the code to the other class. Jared, you might be doing the one where you have to do it's like the wars happened, World War I and World War II. Good to see you here, Max. So I have no idea what that means. So we'll do that right here. And yeah, nice job. You guys are awesome. So cool. Yeah, we're welcome. We're welcome to have you, Max and Gabe. Good stuff right there. That's what we like. So can you send me some more to this class? Our links takes us to the YouTube. You should be going to the Stat 201 site. And Gabe's cool. Gabe, I'm gonna make you a mod, Gabe, so that way you seem like a good guy, Gabe, so we're making you a mod. So glad to have you here. So you get mod status. You're a fan of the channel. You're a mod on our channel now. And do tell people at your university, one, I don't make money from this, so they're more than welcome to use our videos, more than welcome to ask questions. We, of course, I teach, a lot of our videos are just like for our students sometimes if we're just doing like, I teach online, but we want to help out students. We want you guys to have access to stuff. We want to make sure, yeah, Max, glad you like that. So let me send this out to the other class right here. So I am so confused. I'm starting to feel old. We're about to get like some OK boomers in the chat or something on me. So Kahoot code right here being sent out. I'm in last month's memes. Julio, you should see the code has been sent out. Figured it out. Is the email being sent to the? It should go to our class. Go to the announcements. I'm gonna put the computer up now. Just got off screen. Go to our class. Go to the. Thanks, Maggie. So go to our class, go to the announcement right here, and check it out. And let's see, how many people do we have watching? We're at 100, exactly 100. That's cool. I like that. I got the code, just didn't know where to put it in. You want to go to kahoot.it, kahoot.it. So you want to go to kahoot.it. Thank you, Gabe. Awesome having you here. Swing by anytime. Tell everyone, oh, good luck, have fun. That's what that means. Wow, I'm getting old. I was like, what does that mean? So, and you're welcome here anytime. Thank you so much. And we got our mods just in case anything goes crazy. So I love people in the chat seeing each other. It's fun. It's like, yes, I love this. I love this online experience. So is everyone having an easy enough time finding the code? We're going to start the Kahoot up here in just a little bit. But is everyone finding the code? You can't pick our names just in case someone were to do some craziness. Sorry, you can't pick the names. Just helps with when I put the video out there. So your instructor, go to our Stats 101 webpage, and then, so remember, don't put it in the chat. Whatever you do, do not put it. Mods, if you see it in the chats, remove it. Mods, if you see it in the chat, remove it. Don't put the code in the chat because people will try to crash us. Remember, there are prizes. What you should do is go to the Stats 1 webpage. You should know where that's at. Look to the links on your Canvas. If you don't know where it's at, go to the links on Canvas. And you should see that there is a like a Kahoot link under our tabs. So you should have a Kahoot link under the tabs. People one time, and if they do it, and then we review other ways. So it's no fun because then we don't get to do the prizes. So if people do crash it, there's no prizes. And well, I mean, I'll probably give prizes to someone somehow. But it happened one time, and it was just a bummer. And then we don't give them the benefit now, like, darn you crashed our Kahoot. We're just like, well, that's what happens, because I really can't do anything. It's just, I mean, don't crash our Kahoot. And that's why we hide the code. We've not hidden it before, and that's when we got crashed. So sorry, it makes it a little harder to find instead of me just posting it out there, instead of me making it very, very obvious what it is. Yeah, it gets too big, and then Kahoot doesn't like you using that much bandwidth. I don't know if they kick you or it just gets too slow and it crashes it. But you can actually get like Kahoot Premium and like Kahoot Pro, and so you can actually pay for better Kahoots. So, and I might do that one of these days. It's a cool service, and a lot of people are like Kahooted out, but it's fun. And we'll start up some Kahoot here in a moment. We're gonna start the Kahoot at 5:10. Stay on this video. You will be on this video, and so to be clear, you will watch this video while you're playing. We are on ultra low latency. I want you guys to do this right now in the chat, because I'm pretty 99% sure I set this up on ultra low latency. I'm going to snap my fingers, and I want you to have snap written. And when you hear me snap, I want you to type snap, S-N-A-P. So it'll snap in honor of Thanos. And when you hear me snap, type snap. So don't type it yet, but we're going to test the latency here. 1 1000, 2 1000, 3 1000, 4 1000. Good. That's a 4 1000 or 4 second delay. Make sure you're live on this video. So the lower the delay, the easier it is to play Kahoot online. And I was like, did I set the latency up right? Can only stay for 15 minutes and then I have to go. No worries, Casey, this will be recorded. And remember, even if you don't win the Kahoot, the goal is to, and then I have pot roast. Oh my gosh. That's all right, Zach, get that pot roast. It sounds awesome. And pot roast is good. Now I want pot roast. Pot roast, mashed potatoes. So have it, like, reload your video, have it set to as live as possible. And most questions have about 30 seconds to 60 seconds. So you might have to respond a little quickly to some of them. But with that said, it's like, we got Batman down here. We haven't pressed Batman button in a long time.
It's not the question you deserve. It's the one you need.
I still love that button. So we we have Kahoot coming up here in half a second. I just wanted to press the Batman button. Do we have the Kahoot is back button? Is my work? You ready for this? Kahoot is back. So we're about to start the Kahoot here. We're just having fun. I've got buttons to press. I got my stream deck, so I want to press every button. So are there any questions? We're going to start the Kahoot in about 30 seconds here to 1 minute. So the Kahoot will be starting very, very, very soon. Any last minute questions? So which question live, then switch to the tab. If you have to do it on your phone, you can do kahoot.it on your phone. There's Batman right there. Kahoot.it on your phone. And so with the Kahoot.it on your phone, watch it on your laptop, and then click the answers on your phone. That's probably the best way to do this. You could have 2 tabs open. That'll work too, but you have to actually see the questions. I will say the questions out loud, and one of the big goals of this is to use this as a review video, so to use it as a review video. With that said, are there any last questions about doing the Kahoot before we get started here? I'm excited. It's about time for the Kahoot, and we're going to give lots of great advice on what to do right here for the Kahoot and for the test. Any last questions as I bring the Kahoot? We have 115 players, yes. Okay, so I am bringing the Kahoot window down. Pretty sure we have everything set up properly. The code is for our Stats 1 students, so if you know where to find the code, remember, don't put the code in the chat, but if you know where to find the codes for Stats 1 students, if you are a Stats 1 student, make sure to go to the Stats 1 webpage, and then go to the Kahoot section under exams, and there you go. So with that in mind, we're going to play Kahoot. Is everyone ready? We're going to start Kahoot in 3, 2, if I can find the button, 1. The Kahoot is starting. Okay, which of the following phrases helps us identify quantitative variables? So which of the following phrases helps us identify quantitative variables? Which of the following phrases helps us identify quantitative variables? And quantitative variables would be things like numbers. So when we have quantitative variables, we have things like numbers. So you'd have to think about this. Numbers, quantitative. Numbers, quantitative. What would it be with quantitative? Yes! Amazing job on this Kahoot right here. Now I want to point this out. You're going to see more questions right here. And we're going to pause on some of these. When I ask you things like, how old is somebody? If you ask how old is somebody, it sounds weird to say how much years do you have or how many years do you have, but it's a quantity. When you ask things like, a categorical variable, which of these sounds like categorical? So we can get some big Kahoot points. Which of these sounds like a categorical one? What sounds like categorical to you? Oh, have fun snowboarding. Awesome. You're welcome, Adam. Categorical is with groups. So be careful which one, hints for later, identifies which one we're talking about. Categorical makes groups. So if you look, when you talk about kind of what group is it, it puts into a category. When you talk about how much, it's quantitative. This is where I ask my students all the time to think about multiple quantitative variables. We have things like how old is somebody, how much does someone weigh, how tall is someone, how many years has it been? Things like this, all right here is how much is a quantitative variable. Categorical is a grouping variable that creates categories. Which one identifies? That's all the way on the other side of the screen. I can't reach over to it. But there we go. Code should be in the announcement. All that good stuff right there. And under the Stats 1 webpage. So awesome stuff right here. So Jaslyn, the code should be on the Stats 1 webpage and all that good stuff. Glad you guys are liking this right here. Let's do another question and see what you think. Get ready. Remember, the questions are a little quick. It's a Kahoot. So let's get in here, hit next question, and Flying Bat is flown into the lead. Gentle Gazelle is gently in second. Remember, there are prizes for first, second, third. If we do crash, then we'll give out the prizes to whoever won. Which of the following phrases helps us identify identifiers? We already kind of give this away, but let's talk about what an identifier is. An identifier is unique for everything. All identifiers are unique. An identifier will not, cannot, ever repeat. Identifiers are things like, don't give me the answer too quick, Gabe. The answer, Gabe might try to trick you, hint, hint, who knows. But the identifiers are always unique for every observation. They're always unique for every observation. Oh, I see you want to play along. Oh, I'm sorry, Gabe. Man, I wish I could send it to you, but I understand. No, you're doing great though. So which one is an identifier? These are the notes. Take a moment right now, grab your notebook, and with your notebook, start taking notes on what we're learning right here. When we have a quantitative variable, it is a real number that tells us how much of something. We see that down here with the green. So things like your age is how much age do you have? Your height is how tall are you? These are actual real numbers. When we have identifiers, identifiers all the way over there in the red block are things that identify. They are always unique. An identifier cannot repeat. It is impossible for an identifier to repeat because what do identifiers do? I want to see it in the chat. Chat, tell me, what do identifiers do? Remember, we're talking about identifiers. What do identifiers do? An identifier, use the same word. What does an identifier do? It identifies right there, Nicolette. You are right. An identifier identifies. That means it has to be unique. It has to tell us which one. So when an identifier identifies, it cannot repeat or it would not do its job of identifying. So an identifier would be something like, it could be your driver's license number. We could track you by that. It could be an order number. If you go to the gas station, you're like, here's my receipt. It'll have a receipt number that would identify your purchase at the gas station. How much gas you purchased would be quantitative. Did you get diesel or regular would be a categorical variable. And then your receipt number would be an identifier for your purchase. It would identify that purchase. And then there's categorical and quantitative questions we could ask. Bet you can't guess what the next one is. Oh, you want the music? I wonder if, we're going to give this a try. Tell me if you can hear the music. I'm going to give one shot at this music. Do you guys want the music? You guys want the Kahoot music, right? Give me one try at the Kahoot music. This could get crazy here. Okay, one try at this. Everyone's saying yes. Awesome. Audio. There was no music when we were doing it, right? There's been no music so far? Okay. Here this could get very interesting. I'm gonna hit the button. And let's see what happens. I'll try again next one. Which of the following graphics can be used for univariate categorical data? Which of the following, I think I'll fix it. We'll get music here in a moment. Which of the following can be used for univariate categorical? Now we need to understand what univariate means and categorical means. Univariate means only one variable is being displayed at a time. Categorical means it's a question like, what is your class level? What state were you born in? So we're just gonna do one variable and we need a graphic that displays one categorical variable. Oh no! Oh no! So, and the code is available via the Stretch 1 webpage. Oh no! Oh no, no, no. And maybe, I might not be able to get audio for you guys. I don't know if I can get audio because I think I have to change something that I can't change right now. Give me 1 second and I might be able to get audio. So give me 1 second right here. I'm going to do something. And I'll explain the answer to this in one moment. There's a good call for audio. So I'm going back to here to make a change that I want to make. I tell you what, next Kahoot will have audio. I promise that. So I'll do some tests. Next Kahoot, there's going to be audio. Next Kahoot, we have audio. So stay tuned next Kahoot for audio. You want it, you got it, audio next Kahoot. So let's talk about the answer here and what's going on. I see a lot of kind of diversion here on answers. Okay, let's talk about pie charts first. Pie charts are, and here's the way to memorize it. You can make a bar chart of your favorite pies, and you can make a pie chart of your favorite bars. I have now connected pie charts and bar charts. Did everyone hear that? You can make a bar chart of your favorite pies and a pie chart of your favorite bars. Eddie, great question. Univariate means one variable. As I'm just going to ask you, what's your favorite pie? Or I'm going to ask you, what's your favorite bar? And the reason I use bars and pies is that's the name of it. So if you said my favorite pie is Oreo cream pie, that's an awesome one. If you ever had it with the Oreo crust and whipped cream and chocolate pudding, awesome. So when you ask somebody their favorite pie, that is a categorical question. When you ask someone their favorite bar, that's also categorical. You would name a bar, you'd be like, such and such bar, favorite bar. So it's one variable being displayed. It's just we can display people's favorite pies in a pie chart. You can display people's favorite bars in a bar chart. Now, what do we need to remember here is that histograms and box plots are not univariate categorical. Histograms and box plots are univariate what? Histograms and box plots are univariate what? So this is a big note you should have. A histogram is a univariate display of something data. Histograms are univariate displays of what kind of data? They display one, so I should see it in the chat right here. Remember, you can always type this in the chat. Quantitative, you are right. Histograms and box plots display one quantitative variable, which means we could display someone's age, someone's weight, someone's height, and not all at the same time, but we could do it with a box plot or a histogram over there. So we can do it with a box plot or a histogram display someone's age, someone's weight, someone's test score. And then pie charts and bar charts would show things like what state you were born in, what is your favorite holiday? Things like that are all categorical questions, and they display one categorical question. Now, this slide is very important right here, this Kahoot question. What is a non-univariate categorical? So we would have maybe bivariate categorical. More on that to come. So that makes sense now. Yes! Remember, bar chart of your favorite pies, pie chart of your favorite bars, because then that links them. Bar charts and pie charts are univariate categorical. Histograms and box plots are univariate quantitative. Great to see that, Rebecca, right there. We're making sense of this right here. Let's continue on. Is Flying Bat still in the lead? Or Flying Bat, you're doing awesome. But Flying Otter, it's a competition right now between Flying Bat and Flying Otter. This is intense. Flying Otter would win. Flying Bat is what it is, but Flying Otter is amazing. Which of the following graphics can be used for bivariate categorical? Like I said, stay tuned for that question. So, bivariate categorical. Now, there's two answers here because these two are best friends. Two of these graphics here are best friends, and actually, the other two are very similar. So you should see that these are all bivariate displays of data. Everything you're seeing on the screen now is a bivariate display of data. Mosaics are bivariate, scatter plots are bivariate, time plots are bivariate, and contingency tables are also bivariate. But only two of these can be used for bivariate categorical, and the answer is a mosaic plot or a contingency table. Now, a scatter plot is when we say QQ straight enough, no outliers, because scatter plots are bivariate quantitative. That's what QQ stands for. No worries, you got it, you're fine. And then time plots are special scatter plots. A time plot is a scatter plot where the x-axis has time on it. So a time plot is a scatter plot where the x-axis has time on it. Does that make sense? Like a scatter plot is two quantitative variables like height and weight. And then a time plot would be like sales over time. So you could plot how much your sales were over time. And it's a time plot. Both variables are quantitative, and it has an x-axis of time. But a mosaic plot and a contingency table are both bivariate categorical. Could someone tell me in the chat, what are two variables we could display at the same time using a contingency table or a mosaic plot? Does anyone know? And remember, the code's on our page, the Stats1 webpage. Oh no, Amazing Frog. So can anyone tell me two categorical variables you could display? Married and payment method from project 1. You are right. Because if you remember, if you do the project, we allude to these things right here. Time and distance would be a scatter plot, probably like what, no, that'd be a time plot because time would be the x-axis and how far it's gone would be distance. Age and tip amount would be a scatter plot because age is quantitative and tip amount, unless you do it as something being like 10 to 20, 20 to 30, 30 to 40, and then tip being like low, medium, high, that would make it categorical. But especially married and payment amount is contingency table and mosaic plot. I wish I could draw on this screen. A mosaic plot is where it has the boxes, and we probably will see a graphic soon on this, but a mosaic plot kind of looks like a square pizza, and then you've got the different parts inside of it. So think of a square pizza and then the different parts inside of it. And it shows you the conditional and marginal distributions. State where you're born and favorite color. There you go. That's an answer right there. Totally random, but still, that would make a mosaic plot and contingency table. The one with the many colored boxes. You are right. Amazing questions in the chat. Who is leading the way? Flying Bat. And if you do win this, tell your instructor you won, and I will give them the gift card. And then you need to show them maybe on your phone, like take wherever you're doing it, take a screenshot, and then bring it to the instructor and be like, I won, as long as we don't have 10 people claiming to being Flying Bat. So, or you never know what's going to happen. Flying Bat might not win. This will last for another hour about. We're doing great. Let's do this. So we got right here, which of the following graphics can be used for univariate quantitative variables? This is a review question now. Remember, univariate quantitative, I see things right here that would work, all but one of them. There's only one wrong answer on this screen, so figure out the wrong answer and you'll know all the right answers. If you remember, we had from before histograms and box plots. So you might be wondering, what is a stem and leaf? A stem and leaf is a histogram where you can see the numbers. So when we have a stem and leaf, it's just the same as a histogram, except you can actually see the numbers. These are all univariate quantitative displays of data, as in we could display people's age in a stem and leaf. We could display people's weight in a box plot. We could, in a histogram, display people's heights. These would all take one quantitative variable. So good review right here. Lots on the graphics. Who's leading the way now? Flying Bat. Oh, but we got Radiant Falcon. You're going to do some quick clicking. We're going to have everyone clicking away. Let's see this right here. Next question. Find the IQR of the distribution. The IQR stands for the interquartile range. And now I know usually you think I have to subtract Q3 from Q1. But you're not given that information right here. I didn't show you the numbers. I want you to realize, which a lot of people don't realize, is that the graphic can actually help you solve the answer. Remember, when you're looking at the IQR, it's the box of the box plot. So we see right here that this is the minimum value. It's also Q1, that's the median, that's Q3, and that's the maximum. So the IQR is just going to be 2. Let's show the media again right here. And when you look at this, why is the IQR 2? Well, the IQR goes from the Q1 to the Q3. Can people type in the chat right now, what is the min of this data set? What is the minimum pets people own? And just think, it should be a little logical, a little bit logical. What is the minimum? Audrey, you are right. Nice job right there. 0 is the minimum. What is the maximum in this data set? What do we see as a max in this data set? What is the max in this data set? Which, there you go, Kelsey right there. Nice answer. We've got 8 is the max. And this right here, let's make it clear. A lot of times we don't notice this is the mean. Jump shows you the mean to show there's a right skew, right to the high, left to the low, whatever way the tail goes. We've got a right skew to this data set. And if you notice right here, this is where outliers begin. This is the upper whisker. It is not the maximum. It is just where outliers begin. So we have right here where outliers begin, the maximum, the minimum. This is also where Q1 is at, and this is where the median is. Jump shows you the mean, but that's not required for what we do in our class. It's just extra. Thank you, Jump. And then this is Q3. Any questions about this box plot? I'm going to pause on this because when you see a box plot, here's what you should do on your test. Label it. On the test, I'm going to pull out my pen, and I'm going to write. I wish I could write on this screen. I'm going to write here I'm going to write here minimum, Q1, median, Q3. That's just the upper whisker, and that's the maximum. So anything past the upper fence, below the lower fence is for sure an outlier. Maggie, amazing comment right there. You are correct. These are outliers. So if someone told you I have 4 pets, that's high, but that's not quite an outlier. At 6 pets, that is an outlier. Great job, and thank you for everyone helping each other in the chat. So everything right there, but awesome. I have no idea what's going on right here. So let's continue on right here. Next question in the chat. Let's do it. Which distribution has the biggest range? We got some questions going on right here. It might be a little hard to see, but be careful. Be careful. Everyone gets this wrong and loses their streak. I'm getting out of the way. A lot of people lose their streak on this question. Don't lose your streak. Look at the outliers. Don't lose your streak. Look at the outliers. There is an outlier. Don't miss it. Don't miss the outlier. Do not miss the outlier. Do not miss the outlier. Oh no, we destroyed streaks. We did it. Oh no. We did it. No, no, no. Oh no. No, I'm sorry. I'm so sorry. Flying Bat, are you still there? There's an outlier over here. No, I'm so sorry, but why do we do this? Why do we write these mean questions that destroys people's Kahoots? I'm so sorry. But I'm sorry. I will say this, if there are box plots on the test, they're a little bit nicer than this, but I'm just being a little mean. This is actual output I made, And that's that person's GPA, apparently, high school GPA. Respect in the chat. Sorry, but what do we know? What is the learning objective here? The learning objective is whenever we look at the range, we must look for the outliers. A lot of people's eyes immediately go to the end of the box plots. It looks like this has a smaller range. So a lot of people were saying the fort had the biggest range just because you were looking at the box plot. Or you might have saw this outlier, but there is an outlier right here. Hopefully, so someone got it. Pay attention to those outliers, max minus min. The range for this one is something like 4.6, because that's like 4.7 minus 0. So learning objective. I'm sorry. Someone else is very happy. I'm so sorry. But I saw it and I was afraid. Yeah, no, it's harder to see over there, but it is an outlier. So don't worry. Don't worry. So take a note. Take a note. You got your notebook out right now? When doing max minus min on box plots, remember outliers. I purposely made this question to catch people. I made this question so people would get it wrong. Just bye-bye streaks, gone. I like that, Mike, right there. Great comment, Mike. So, Mike, I'm going to make you a mod right here. So there you go. If on campus didn't have, here we'll see. If on campus didn't have an outlier, would the fort be the correct answer? Yes, great answer right there. It looks like the fort has the second biggest range. And yep. And so write in your notebook, when calculating range, always remember to look for outliers. A lot of people does this. This video will be up afterwards so you can watch it. Remember to take these great notes. We're offering some great suggestions for things people commonly make mistakes on the test. Great questions. And did you find the code there? It should be on the Stats 1 webpage. We just don't post it in the chat so we don't get people spamming us because they will try to crash us. Great stuff. Everyone, amazing work. Let's see here. Flying Bat. Destroying it. Amazing job. Let's see right here. Which of the following is not a way to describe univariate quantitative data? Which of the ways is not a way? So we have everything right here. Be careful. Be careful. There are only 3 ways to describe univariate quantitative data. Here's a hint. We were just talking about the spread in the last question. So this is not the correct answer. Spread is the thing like the IQR or the standard deviation. Spread is either standard deviation or IQR. Center is either mean or median. And shape, there's all the answers, is uniform. But those are not the answers. Great job. Form is when we're talking about bivariate quantitative. Strength, direction, unusual features. Strength, direction, form, unusual features is bivariate quantitative. Let's pause on this for a moment more. Here's a big learning objective. Have your notebook out and be writing this down. First, second, third get the prizes. You are correct. So, and there'll always be candy. There'll be candy in the office and Starbucks gift cards for first, second, third. So if you notice right here, this distribution is very skewed to the what? This distribution is very skewed to the what? Very, very skewed to the what side? So we're talking about the shape of this distribution. It's very skewed to the right. I have now said this is a unimodal right skew distribution. I'm talking about the shape of it. So shape is a way to talk about just one of the 3 aspects of a distribution. Now we also need to talk about the center of it. Since it's right skewed, what is the best way to describe the center? Since it is right skewed, what is the best way to describe the center? Kelsey, you're right. It is median. Median is the best way to describe the center because when it's skewed, that's going to inflate the mean. And since we're using median, what should we use to talk about the spread? We should use the what? IQR, you are right. The IQR is on the box plot also. So make sure you have a note that says median and IQR go together. And we're talking center and spread. Median, center, spread, IQR. And mean and standard deviation go together when the data is unimodal symmetric like the normal curve. No. So we have right here, that the median and IQR are measures of center and spread for skewed data. Mean and standard deviation are measures of spread for normal data, center and spread for normal data. Mean and standard deviation are measures of center and spread for normal data. Great stuff right there. Great stuff. So we understand what the shape, center, spread is. It's for univariate quantitative data, and that is for bivariate right here. That is a bivariate way of talking about quantitative data. Flying Bat, charming dog. Nice charming dog right there. Probably a golden retriever or something awesome. All dogs are awesome, though. So what is the best measure of center for this distribution? Kind of gave that one away. A review question now. You have 2 measures of center on here, so please don't answer the 2 things that are not measures of center. So if you're doing this, remember that IQR is not a measure of center. It's a measure of spread. And standard deviation is not a measure of center. It's a measure of spread. So do this right here. What is the best measure of center? You need to look at first the shape, identify that that is skewed. And since it's skewed, Julio's right there. Median and IQR, you are right. And so nice answers in the chat. We're on track. We're doing some good learning right here. So center can only be median and mean. How do we know which one it is? We look at the shape. Remember to do it in this order. Shape, center, spread. By looking at the shape, we can identify what should be used for center and spread. So when I look at this shape right here, I say, that's right skewed. Since it's right skewed, I am a teacher. Since it is right skewed, this is going to be best described by the median, and it's also going to be best described by the IQR. The median, Max, you're awesome. So we have the median and IQR are based on, the median and IQR are used for center and spread for skewed data. Skewed data is the median and the IQR for center and spread. You guys are awesome. You guys, so awesome. Matthew, you're awesome too. Oh, man. Thank you so much, everyone. You guys make my day. Let's go on here. Let's do the next question right here. I'm sorry. So I'm forgiven for the snap, right? I'm forgiven. What is the best measure of spread for this data? You guys got this. You know that there's only 2 measures of spread on this screen right now. When you hear spread, you should think IQR and you should think standard deviation. IQR and standard deviation are the 2 measures of spread right here. We've only got 2 measures of spread right here. We do some reviews online. Check out the channel, stat201 at utk.edu or stat201. We are stat201 at UTK. So that is us right here. So with this right here, we have that the best measure of spread is the IQR. Make sure, once again, who has their notebook out? I want to see some yeses in the chat. You got your notebook out right here. I want to see some yeses. So we're the Haslam College of Business at the University of Tennessee, Knoxville. You do get more points if you answer quicker. You got your notebook out. You should have a note right now that says mean and median are measures of center. Standard deviation and IQR are measures of spread. We know which center to use and which spread to look by looking at the shape of the distribution. The shape of the distribution. The shape of the distribution. So, that's totally fine. I am, but not everyone else has to be. The shape of the distribution tells us which center and spread to use. Once again, when I look at this distribution, I say it's right skewed. Why is that? It's got a long tail going out to the right. And if you actually notice, that's the mean right there, which is higher. Imagine this. Let's do a quick example where we find the mean. What is the mean of 2, 3, 4? Just think about it real briefly. What is the mean of 2, 3, 4? What is the mean of that? 2, 3, 4. What is the mean of that? 3. You just average the numbers and they average to 3. What is the mean of 2, 3, and then let's say something ridiculous here. 2, 3, I'm thinking of a number that really works. 2, 3, 85, and I purposely picked 85. What is the mean of 2, 3, 85? Can you do that one? 2, 3, 85. What is the mean of that? 2, 3, 85, 30. You just add 2 plus 3 plus 85 and you get 30. So when you look at that, what is 85 doing to the mean? It's inflating it. So when you have outliers like extreme values up here, it inflates the mean, making it unreliable. Imagine if you went to work for a company and you found out that the mean salary was like $100,000. You'd be like, that's awesome. You'd be like, the mean salary here is $100,000. But what if it's because the person who runs the company makes $20 million and you're like, well, wait a minute, there's only 40 people at this company, and when we take them into account, they skew the data. So what would be a better representation of the salary if there's big outliers? What would be a better representation of the typical salary at the company if there's extreme outliers? The median, because that would be the 50th percentile. That would say 50% of people make this much or more at the company. Now, when you think about the median is the 50th percentile. The IQR is the 25th and 75th percentile. Notice how the median and IQR are based on percentiles, so they don't get impacted by outliers. Mean and standard deviation do get impacted by outliers, though. So mean and standard deviation are their own thing for when data is normal. Mean and standard deviation are the measures of center and spread. Mean, standard deviation, center, spread, for when data is normal. Our data in this example is very right skewed. Due to that and the outliers, we're going to use the measures of center and spread of median and IQR. The median can be seen right here from the start of the box plot, the minimum, the IQR can be seen right here at the Q1, which is also the same value of the min, all the way up to Q3 right here. And the median is right here. So the IQR is 2 and the median is 1. The IQR tells us that the middle 50% of people have pet amounts that range from 0 to 2, which is an IQR of 2. The median tells us that 50% of people own 1 pet or more or 1 pet or less. You're welcome. I'm glad. This is what I like to do. I like to help you guys out with the view. Are you monetized? We're not monetized, so there's no ads on our videos. We're just here to educate. So that's what we like to do, help out and help people learn. How can we do? So let's continue on right here, and we will continue on. Let's see, what do we have? We have a question right here. Which way is this distribution skewed? So let's see, which way is the distribution skewed? Which way is the distribution skewed? Does anyone know which way is skewed, left or right? Left or right? And mods, feel free to hide users or whatever you want. Definitely. So all this good stuff right here, it is skewed to the right. Now, how do we know if it's left or right skewed? How do we know if it's left or right skewed? I'm going to pull up some stuff right here while we get this going on right here. How do we know if it is left or right skewed? That might cause trouble. So how do we know if it's left? Thank you, mods. So how do we know if it is left or right skewed? The tail goes to the right. The tail indicates the skewness. Thank you all mods in right there. So while we're doing this, awesome. Thank you so much. Does it have tail? Does it have outliers? If you notice right here, the right skew is indicated by the right nature to it. We have a tail going out to the right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. Does that make sense right here? Does everyone understand that this is right skewed because the tail of the distribution and the outliers are on the right side of it, the high side of it. All of that good stuff right here. I like that right there, Kelsey. Awesome in the chat right there. Cracking me up. My QQ straight enough. Well, Carson, thank you very much. I've thought about it. I appreciate it. One of these days we might. If I were to monetize videos, it would not be on the ones we use like to help the students. We'd put the broader range ones to help, and then we could monetize. And we wouldn't want you guys giving us all your money. I do want to get on Twitch also. We're trying to do the Twitch stuff, and we could be Twitch affiliates. And if you have your Amazon Prime, any student could give us their Amazon Prime, and then we would use that money for tutoring for students and for pizza parties. So we would just do pizza parties and tutoring. So you'd get free tutoring and free pizza party the more Twitch subs we had. And so Carson, get a hold of us. My email is just bstevens@utk.edu. And if we can get Twitch subs, we just want to give it back to the students. So I'm going to keep trying to have that happen. But awesome. Let's continue on here, Kara. We got you another question coming right here, Kara. Let's do this. What is Q3 for this data? Let's do some Q3 right here. Where is the Q3 at? This is something you should know from all of this review. If you've been following along, you should know where Q3 is at. What does Q3 mean? What does Q3 mean? Q3 is the 75th percentile. When you think of Q3, think of 3/4. How much is 3/4? 3/4 is 75% of the data. 75% of the data is below Q3. Maggie, you are right, and you get mod status for that right here. I can't mod people right now, but still, we'll mod you another time. But we have here that the Q3 is going to be at 2. We need to notice that the Q3 is at the top end of the box plot. The Q3 at the top end of the box plot. And this is the minimum and Q1. Take a note. Know how to read box plots. When you get a box plot, make sure to identify all of the numbers on it. Once again, label it with the min, the Q1. It's in the same spot on this one. The median, the Q3, where outliers begin, that's not a percentile, and then this is the maximum. Once again, the range of this is 8. Don't worry, Fish, we will have this recorded. You can check it out at any time. What is the last chapter on the exam? Chapter 8, which is just regression wisdom. Regression wisdom is chapter 8. It's a very, very, very short chapter. So awesome stuff. And so glad to have you here, Carson. Thank you so much. You're welcome to hang out and ask questions and relax with us right here. Next, but not least, an outlier begins. That is when we use z-scores. Outliers are extreme outliers with z-scores at 3 standard deviations. Light outliers are at 2. Got a little Batman quote right there. Awesome stuff. Thank you, Max. You guys know I love some Batman and Joker. So with this in mind right here, what are possible options to add to a pivot chart? What do we got? Pivot chart stuff right here. We've got data tables, data labels, chart titles, axis titles. Wait a minute. It's almost like all of those sound like they are possible. This is college right here, Carson. This is College Stat 201 at the University of Tennessee. So we have data labels, data tables, chart titles, axis titles, and the questions are about to get a little more difficult after this. So what are all the things that we can enter? The answer is in 3, 2, 1. Guess what? It was all of them. Remember, you can add all these options in. The chart title is going to be the title up at the top. The axis titles is going to be on the sides. And the data labels or data tables is going to get it for you right there. With this in mind, we should know other things. I think I might have them listed. Here's the things you should know for pivot tables and pivot charts. You should know what you can add to them. We're totally fine. Carson's awesome. Carson's a great guy. I'm so glad to see what's in your recommended. They see that people are watching our channel, Carson. They recommend it to people. But one of these days we might just start. It might just, who knows? It gets in people's recommendeds. But we're so glad to have you here. Check out, we're just teaching education online. So all of these can be added. But here's another important thing to know for pivot charts. We need to know what things like the rows and the columns do. Rows and columns separate the variables. Then we also know that the value is what is being displayed. Remember in the project, we displayed the average, I think it was, tip people were giving. So you can display the count of tips, the sum of tips, the average tips. All of those different things can be displayed. Last but not least, we have the filter. The filter allows us to remove things. Imagine if we only wanted to look at freshmen and sophomores. Well, we could filter out juniors and seniors. So, Max, you are awesome. So we have all of these options right here on the pivot table and pivot chart. Good stuff. Next question. We're about to get to some normal curve and some regression stuff. Flying Bat is still doing awesome, but Charming Dog is following right along. Which of the following is a field we can edit in a pivot chart? Probably all of them. Can't remember what I put. We've got columns, rows, values, and fields. Hint, hint, hint. All of them. And when you see things in this review, make sure you know that, oh yeah, and you should definitely check that out, Carson. Make sure you know what each one of these does. Columns and rows let us split apart by certain variables. And then the values is what we're actually showing, and filter lets us filter things out. Like maybe we say, okay, we want to only look at people in 4 states, so we could filter out every other state. So with this right here, they're all correct, and I think we got that understanding underway. So let's hop to some more difficult questions. I think it's going to get difficult now. Get ready. Here we go. On the standard normal curve, what percent of area is above 2? On the standard normal curve, what percent of area is above 2? So if I could draw on this screen, which I wish I could, not right now, but I do at other times, I would put a line right here on my curve and I would draw to the right of it. Now, there should be an answer that jumps right away to you. Now, be careful. When you hear 2, you should think 95. 95 is not the answer. But I think a lot of people might have the answer right now because you've done this a lot, and we sometimes put the empirical rule on the test. The empirical rule is the numbers, and I want to see it in the chat. Who knows the empirical rule numbers? So what do we have for the empirical rule numbers? We have 68, 95, 99.7. Those are the numbers. Oh, no, don't worry. And Carson, great job. Carson, here's a really, Carson, I'm throwing Carson 1,000 points. He can't even use them because he's not in our class, but that's fine. Carson, what we would do here if we want to do the area above 2, imagine that this is a pizza right here. So just think of it, it's a weirdly shaped pizza, and you're going to put a line right over here, right where I am pointing my finger. And then you're just going to graph over to the right of it. How much of that pizza does it look like I'm shading? Is that a lot or a little of the pizza? Just a tiny, tiny sliver. And don't worry about it, Carson, because other people got it wrong too. But when you look at it, it might have you believe that it's 2.5. But if you notice the numbers people were typing in the chat, Carson, you're right, it's little. Carson, we had a person last semester join us for the first one. Carson, I appreciate you here because we're here to talk about stats, and I'm going to do some magic on the screen right now. Time for Brian to fly around the screen. So what you heard in the chat is you heard 68, 95, 99.7. In between here and here is 68. I'm trying to move my hands. It's hard with a mirror image. 68 is between -1 and 1. I'm going to have to do Ant-Man right here. Whoops, wrong thing. Or to go right here and just Ant-Man. Now I'm off the screen. 68 is between -1 and 1. And then 95 is between -2 and 2. So if 95... it's so hard to see. If 95 is between -2 and 2, then what is above this hand right here? If 95... everyone's talking about this scroll thing on campus. I have no idea what's going on. If 95 is between -2 and 2, what is outside? What is outside if 95 is between -2 and 2? What is outside of it? 5%. You are right. Nice job right there, Anna. So you have 95% between it, 5% outside. Then what do you do to get the 2.5? You cut it in half. So this little sliver over here is half of 5%, 2.5 on either side. So we always do things like 95 in the middle, 5% total outside, 2.5 in either hand. You can do it with the other numbers, like 68 would be between -1 and 1. There will be some questions on here like this, but knowing the 68, 95, 99.7 is how we can use the empirical rule. So the normal curve is 100% symmetric. You are correct. And so, exactly, yep. There's, I wonder if you guys mess with me. Like, I do like squirrels. So someone's like, Brian likes squirrels. Tell him there's a squirrel on campus. And I hunt like all day for squirrels. I'm just catching Pokemon. On the normal curve, what percent of area is below 1? So now we need to find the area below 1. Let's go right here, and we would have a line going up right here. So what area is below 1? And so remember, Carson, use this as though we're looking at this curve, and we draw a line right here, and we shade below it. That should eliminate a few answers. It should not be less than half the curve. So this has to be more than half. So there should be a few answers that jump out. So... oh my God. You guys are awesome in the chat. So with this right here, oh, pretty good. The 68 tricked people. And that's kind of all right. Don't worry. What do we have? What is between -1 and 1? What is between -1 and 1? Where is this? -1 and 1 has 68. What is above 1? What is above 1? Just what percent is above 1? The percent above 1, which would be this hand right here, the percent above 1 would be how much? 16. So what's below 1? Below 1 is how much? If 16 is above 1, below 1 is how much? If 16 is above 1, below 1 is how much? 84. You guys got it. You guys got it. Great job on these. And I've got lots of videos on practicing this. Great job right there. That is correct. 68 plus 16. You are correct. Nice job in the chat. And great answers. Great learning. Flying Bat still flying through to the lead. Gonna get that Starbucks gift card. What percent of students are expected to make below a 60? Now we no longer have the z-scores. So when you look at this right here, here's my big learning objective. Always write the z-scores below it. So always write the z-scores. And if you're practicing this like we just did, I do a lot of review questions in here to make sure you can practice this and get it down. You should be like, okay, wait a minute. 60 has a z-score of what? 60 has a z-score of -1. Remember we just did 68% between -1 and 1, outside 32, and that'd mean below 60 would be 16. Great job on the answers right there. You figured out the z-score and you figured out what percent is below it. Now, please take a note on this. Have your notebook out. Anytime you're given these curves on the test, anytime, what are we going to put below these curves? Either the in context or the what below it. Like what numbers am I going to write? I was just doing this in class a moment ago. I'm going to write the what's below it if it has the in context numbers. I'm going to write the something scores. I'm going to write the, like I'm going to do this. I'm going to write the z-scores. Exactly. I'm going to put all my z-scores below it. I'm going to draw on the curve. I'm going to do as much as I can to help myself out. I'm going to draw my z-scores. So put your, this would be, where Brian's holding his hand right now is a z-score of what? Where Brian's pointing his finger is a z-score of what? What is the z-score right now right here? Let's see who's got in the chat. Not 3. Great job, Heidi, though, and Nicolette and Anna. You're right. It would be 2. This is 2 standard deviations. What is the amount of the standard deviation on this curve? This is a normal distribution with a mean of 70. Oh, no worries, no worries. It's normal distribution with a mean of 70 and a standard deviation of 10. And then draw below it, write 0. I can't reach that. Write 1 there and 2 here and 3 behind my head back here. So put the z-scores on it, draw on these curves. It's a big help. There's a video if you're looking for a really great example. So make sure to, don't put the code in the chat. If you're looking for a really great example, make sure to look at the lecture I just did. And in the lecture I just did, we did some examples of it on how to solve it. So one, if you're watching this video right now, there's a video I did just before this where we did examples using this right here. So we did examples of this just before. Let's take a look right here and let's continue on. What percent of students are expected to make above a 55? So when we look at this right here, this one is tricky, but I want you to think about it. What percent of students are expected to make above a 55? And if you look right here, we have the area above 85, and then we have the area below 55. This one's super tricky. So this one is really tough. And why is it really tough? Total boomer, total. I'll let the mods handle that. So with this in mind right here, this is the trick to this question. You might think, how can I possibly get the answer to this? How in the world can I possibly get the answer to this? Remember that we're looking for this area, but on the other side. So how are we going to get the area on the other side of it? I'll explain in just a moment. We're going to get the area on the other side of it in just a second right here. Now, if you notice, you're probably between 2 answers, but you're wondering how you would choose. Let's see how that's done. Now, the question asks students who make a 55. This is a really great thing right here. So when we look at this right here, yep, this would be a good multiple choice question on the test. And a lot of people might say to me, well, how could I figure this out? I want for everyone to take a moment right now and find the z-score of 85. Take a moment and in the chat, find the z-score for 85. You should do 85 minus the mean over the standard deviation. Go ahead and tell me the z-score for 85. What is the z-score for 85? Does anyone have any idea? What would be the z-score for 85? 1.5. Now, when you think about what is the z-score for 55, what is the z-score for 55? Because it's on the exact opposite side. The z-score for 55, what was the equation again for z-score? It's observation minus mean over standard deviation. So it'd be 85 minus 70 over 10. And look, it's 1.5 standard deviations above the mean, and 55 is 1.5 standard deviations below the mean. Now, this is where people say, well, how can I possibly tell what this area is on the other side? Well, here's the thing. It has to be between 2.5 and 16%. And why is that? Well, I'm going to use the one over here, which is the same amount of area. I put it over here so I could talk about it. Everyone tell me, what is between, I'm going to use this hand here, what is between -1 and 1 z-scores? What is between -1 and 1 z-scores? Good to have you here, physics. What is between -1 and 1? 68. So what is outside of -1 and 1? What is outside of -1 and 1? Outside of -1 and 1 would be 32% total. And that would mean I'm pointing right now above my arm right here, above my hand, is what percent, if 32 is the total outside of it. Audrey said it right there in the chat, 16% each. So would you agree to me that if I were to shade from here over, from my hand over, it'd be less than 16% of the area? But then we go over to here, and what is outside of 2? 2 is the number 95. So inside of -2 and 2 is 95. What is the outside? It's so good to have you, Proxy. So with this right here, what is outside of it? 5. What is my arm worth right here? What is the area above this? The area above it is 2.5. So the numbers you just gave are somewhere between 2.5 to 16%. And look at the only possible answer. You said this area that's shaded has to be between 2.5. Oh no, I said above. Oh, and it's the reverse of that. It'd be, sorry, been teaching for a while today. It is between 97.5 and 84. I do data and data analytics. I don't do rational numbers and fractions. Exactly. So if you notice, I said 2.5 to 16, but it's the reverse of that. It's going to be between 97.5 to 84. So I was just thinking the wrong way. I thought it said below. Sorry if I messed up anyone's streak. That was not on purpose, but it's the reverse. It's not 2.5 to 16. It is 97.5 to 84. So thank you, mods in the chat right there. You guys are awesome. So let's continue on right here. Exactly. Mods doing their work. So mods, you can go ahead and do your work. We appreciate it, mods. So let's continue on right here. The regression model, let's take a look at it. Write the regression model. Yes, I need to hop out of the way. I'm getting out of the way. Don't want to knock things over. Oh, God. Ah. Okay. Hopefully I'm not blocking the right answer. I could be. I think I might. Am I not? Oh, I think I am. It's hard to see. Weekend text. Let me explain. We'll see. I blocked the right. Good. I didn't block the right answer. Okay. Let's look at what we have right here and how it works. With this right here, we have right here that the intercept is going to be the value of B0. Now, we reviewed this a lot coming up to this right here. We have that 115.5 is B0, which is the intercept. And then weekend text is 1.3. Can people tell me in the chat right now, what is 1.3? 1.3 is the what? 1.3 is the what? Can you tell me 1.3 is the value of this? Who knows in the chat? Not the mean. There we go, Ashton, the slope. B1, those are right answers right there. Great job. And remember, Jameson, right there, that is the value of the slope. That 1.3 is the slope. It's B1. Nice right there, Lucas. Great job. That is the value of the slope. Let's hover over it. This is the slope coefficient, and it's also B1. This is B0. Now, right behind my head is the significance of the model. So the significance of the model, don't worry, how would you know weekend text is on the, yeah, exactly. This one, so did I mess it up? It should be weekday text. I put weekend text on both sides. Sorry, that's a typo on my part. Maggie, if you're in my class, 10,000 points. So Maggie, thank you so much. It should be weekday text, and that's what happens when I try to change my Kahoot. So remember, and what's the difference between these two down here? Oh, look at it. In B, I'm multiplying the intercept by it. You can't see it. I'm going to get out of the way. So in B, I'm multiplying the intercept by it. But who here in the chat can write out just the general form of the regression equation with the y hat, start writing it, y hat equals something plus something times something. What is the general form? You got this. We're not done yet. You got this. Y hat equals B0 plus B1x. You are correct. And so if you look at this, this is where we have B0. This is where we have B1. This is where we have X. So this had the wrong thing being multiplied right here. It was doing B0 times X. So that was in the wrong spot. And just look for the B0 plus B1x. Great job in the chat right there. And we do review this in the video before this. So if you're watching this, this is meant to be a kind of a quicker review, and we do review this in the video before this. Thank you, everyone in the chat. Amazing answers. Kara, thank you very much. What does y hat mean? Y hat is the predicted value, and since this is a Kahoot, it won't let me put the hat on top of this, but y hat means predicted. For each weekend text, we would expect weekday text to increase by yes. And remember, predict. Yeah, expect. You are correct, Julio. Julio, 1,000 points right there. For each weekend text, we would predict weekday text, and sorry I didn't put weekday right there, to increase by this, when increased by 1.3. Good to see you here. And so with the intercept, we have when weekend text is equal to 0, we expect weekday text to be equal to 115.5, and that should say weekday text. Sorry about that. Continuing on, we're going to have some more interpretation stuff coming up right here. I can promise you that. Which of the following is not a word or a phrase to describe correlation? Which of the following is not a word or phrase to describe correlation? We have a few right here. Remember, there are ways to describe correlation, and there's a ways to describe just univariate data. What do we have? Should be strength, one of them. Should be form. These are all correct answers. Strength, direction, form, and unusual features, which means the wrong answer here is shape. So shape was a wrong answer. Nice job for those getting the wrong answer. We might be losing people on the Kahoot, but we're still playing strong right here. Let's continue on to the next question. A little bit of review right there. So awesome. Who's Flying Bat is still in the lead. Charming Dog and Balance 10. So great stuff right there. Interpret R squared in context of the problem. I love these ones. And hopefully I'm out of the way. Oh, I'm going to get out of the way. 2 seconds. Oh, look. I'll just hang out up here. There we go. So here we are. Interpret R squared in context of the problem. I can just kind of look down on the problems right now. So this is where we are predicting weekly hours reading from somebody's age. So we're trying to explain how much someone reads by their age. So what would we do right here? So shape is not the same thing as form. Emma, shape is not the same thing as form. Great question, Emma. Shape is not the same thing as form. Great question. Form is linear and not linear. So this is a big one. Notebooks out. Have your notebooks out and get ready. Blank % of the variation in Y can be explained by the variation in X. And so I didn't have enough room to write this right here by the variation. I literally was running out on these Kahoot questions. I want to see it in the chat, and I want people to start writing it. I have to move a little all the way right here. But here's the R squared up here. Blank % of the variation in Y can be explained by the variation in X. Blank % of the variation in Y. Put this in the chat. I want to see it. I want to see 20 people writing this in the chat right now. Blank % of the variation in Y can be explained by the variation in X. R squared interpretation is blank % of the variation in Y can be explained by the variation in X. I'm going to keep saying it until I see 20 people in the chat. 94% of the variation in weekly hours reading can be explained by the variation in age. Anna, I think everyone won our class, 20,000 points, Anna, right there. So, but remember, blank % of the variation in Y can be explained by the variation in X. We need to see who's got the answers in the chat. 94% of the variation in weekly hours reading can be explained by the variation in age. You are correct. And what people are writing here with the blank % of the variation Y can be explained by the variation in X. Even if you're copy pasting it, that's good. I want to see you writing it because we need to know how to interpret it. 94% of the variation in weekly hours reading can be explained by the variation in someone's age. And now I might be giving this away. I might be giving away later questions. I think I am. We'll do those interpretations in seconds. But does everyone see in the chat right now? We have blank % of the variation in Y can be explained by the variation in X. And then we put it in. Nice job right there, Freddie. We put it in and we say 94% of the variation in weekly hours reading can be explained by the variation in someone's age. Once again, this that I'm hovering over right here is the R squared. This is the Y variable. This is the X variable. 94% of the variation in weekly hours reading can be explained by the variation in someone's age. Excellent work right there. Keep it up. Okay, next question. Flying Bat, still in the lead. Charming Dog, Balance 10. Let's see what happens. Explain the slope in context of the problem. Now, WHR stands for weekly hours reading. Now, remember, here is the interpretations you should have in your notebooks. I hope that's true, Matthew. I need to get out of the way. No. Don't worry, green's a wrong answer. Is red a wrong? Is blue a wrong answer? Nope, blue's the wrong answer too. It's red's the right answer. Okay, let's talk about how to do this. So, oh, nice. You got it right there. Let's see. Great answers in the chat. You can give it away towards the end if you want. Just see people practicing up. Okay, so let's look at this right here. When we have, and actually I think I got to go back to where I was at. Let's go back down here. I should set that up as a scene transition so I can do it really quickly. Okay, so what do we need right here? We need to make sure we say for each, for each 1 unit increase, in X, we expect Y to increase by blank, or B1. For each 1 unit increase in X, we expect Y to increase by B1. And you can say the on average part. Some teachers prefer that. For each 1 unit increase in X, we expect Y to increase by B1 on average. For each 1 unit increase in X, I want to start seeing this in the chat. Put it in your notebooks. Get ready. For each 1 unit increase in X, we expect Y to increase by B1 on average. Start writing it. For each 1 unit increase in X, we expect Y to increase by B1 on average. I don't see it yet. Yes! Kaylin right there. Awesome. For each 1 unit increase in X, we expect Y to increase by B1 on average. Yes. For each 1 unit increase in X, we expect Y to increase by B1 on average. For each 1 unit increase in X, we expect Y to increase by B1 on average. Memorizing this, how do we use this now? Let's put the variables in here. For each 1 year increase in someone's age, you see that's a 1 unit increase in age. For each additional year someone gets older, I would expect their weekly hours of reading to increase by 10 on average. For each additional year of age someone has, I would expect their weekly hours of reading, which is Y, to increase by 10 on average. Now, it's a bit of a crazy equation. Probably wouldn't work out that way, but this is what it says right here. It's not really that logical, kind of a fake example right here. For each 1 unit increase in Y, we expect X to increase by B1 on average. You are right. And if you know how to then phrase it by saying for each year of age someone is older, we would expect their weekly hours of reading to increase by, this is B1, by 10 hours on average. And that's units of Y because we're expecting weekly hours of reading. So it's always 1 unit increase in X. We expect Y to increase by this value. Very important. Remember, this is Y hat, that's what we're predicting. This is B0, which is the intercept, and this is B1, which is the slope, and this is X, which is the thing that it's using to explain Y. X explains Y. So great stuff right there. Great comments in the chat. Good practice. Let's do it. Flying Bat, you are destroying it. Let's see, explain the context of the slope. I'm going to get out of the way. I should remember. I should just hop up this way. There we go. Having too much fun today. So when you do the intercept, we need to know our blanket interpretation for the intercept. The blanket interpretation for the intercept, when age is equal to 0. Nice job. You are correct. That does seem right to me. Bingo, right there. Amazing job in the chat right there. It's when age is equal to 0, we expect Y to equal B0. I'll mod up. Sure, mods, can you handle that? Well, no, they're on track now, so I think they're fine right now. But and thank you, mods, so much. So yeah, just make sure to stay on track. We don't mind if people stay on track, but we always want to stay on track while we're doing it. But thank you very much. Mods are awesome. So write this down. I want to start seeing in the chat. When X is equal to 0, we expect Y to equal B0. When X is equal to 0, we expect Y to equal B0. So start writing that in the chat. Start writing that in your notebook. If you have your notebook out, if you're getting ready for the test, don't think, I'm just going to listen. Don't listen to me. Write it down for yourself. Get that practice. When X is equal to 0, we expect Y to equal B0. Actually, the shorthand of it right there in the chat. When X is equal to 0, we expect Y to equal to B0. When X is equal to 0, we expect Y to equal to B0. When X is equal to 0, we expect Y to equal to B0. Exactly. So now we got to slow it down some. We've got to slow it down and think about what this means. What is X, what is Y, and what is B0? We have to go to our equation. So we're going to look at our equation right here. When X, which is somebody's age, you can't see it. When somebody's age is equal to 0, we expect their weekly hours of reading to equal negative 168. This is what we call an illogical intercept. How can you read negative? And if you were 0 years old, sure, top 10 get 10,000 bonus points. So when X is equal, Anna right there. Anna reading negative 168 right there. When X is equal to 0, we expect weekly hours of reading to be negative 168 right there. So great stuff, awesome stuff in the chat. You guys are so much fun. So Flying Bat, destroying it. Remember, email me if you won, and I have the Starbucks gift cards. We'll bring them to the exam, and you get a $10 for winning, $5 for second and third Starbucks gift cards. Which one is not a condition for regression? Oh, man. Probably click. Okay, good. There is a wrong one. I thought for a moment there wasn't. This is Brian broadcasting for about 3 hours straight. Jason comes in here. Jason does it. And do we still have, I'll show the outros and intros again at the end. We'll go into a time loop at the end is what we'll do. When X is equal to 0, we expect Y to equal B0. Yep, that's it. And so who in my class knows it? Rebecca. QQ, straighten up. No, outliers plot doesn't thicken. If you want more info on that, we've got videos on it. But QQ means that both variables are QQ means that both variables are quantitative. Straight enough means a straight line well approximates the relationship. No outliers literally means that there's no outliers. And plot doesn't thicken means the plot does not get thicker or thinner. I know it's a very quick review of the 4 conditions for regression. We should also remember that the 4 conditions for regression also house the 3 conditions for what? The 4 conditions for regression also house the 3 conditions for what? So there's 4 conditions for regression. They also house the 3 conditions for what? Correlation. So correlation is QQ straight enough, no outliers, and then regression is QQ straight enough, no outliers, plot doesn't thicken. So just remember, if you know the 4 conditions for regression, you also know the 3 conditions for correlation. There is no technical order to them, but it makes sense to do them in order, and that way you can just be like, oh, there's a 4th one for regression. And feel free to ask, ask any questions you have to anything related to the class, and I really appreciate everyone here learning, practicing, good stuff. Let's continue on, and let's do the next question right here. Is the following residual plot good or bad? Is it good or is it bad? There is a chapter, I think, 7 question that looks like this. I'll give you a hint. I'm not blocking any of the right answers. And I was easily able to identify. So is the following residual plot good or bad? Residual plots, giving away some answers right there. The residual plot is going to be centered at 0. And it also shows us where things are above or below the line. So don't worry, the answer is already there. So the answer is it is good. Now, people are probably wondering, but remember, I wonder if I can do it. 2 seconds, watch this. I want to show some good residual plots. Do a little. 2 seconds, I want to show a good residual plot here. Go back to full screen. Okay, so QQ straight enough, no outliers. What does that mean? QQ means the following. So when we talk about QQ, we're talking about Y and X are quantitative. If you see a scatter plot, it satisfies QQ. Like, you can't do the remaining conditions if QQ is not met. So QQ is met unless you don't have a scatter plot. If it's not going to be QQ, then like QQ means bivariate quantitative. If you're in another class, please write like quantitative variables. I accept QQ because it matters more. You can tell me that both variables are quantitative. That's what it means when I say QQ. Like, I like QQ because it means you have a quantitative X and a quantitative Y, so it's QQ. And it kind of starts out the chant, QQ straight enough, no outliers, plot doesn't thicken. So we do that chant in my class all the time. And then when we say straight enough, we're going to draw the right example here and the wrong example here. And you know what? Let's put a wrong example down here. Someone earlier was asking about a mosaic plot. This is the counterexample of when it fails. A mosaic plot is not quantitative. We get space pen back in the lecture. So a mosaic plot is not QQ. So these are all the right ones. Oh, whoops, wrong colors. Got to use the green for the right one, and got to use the red for the wrong ones. Everything down here is incorrect and would not pass the condition. There are many ways you can not pass QQ, like having categorical quantitative, like side-by-side box plots would not do regression, but a categorical is not QQ. The next condition right here is straight enough, and remember, everything on the top is going to pass. So we're still doing all the correlation conditions and regression conditions. And so straight enough, well, it looks like the one we just drew. Straight enough, don't worry if it's not perfect. It can have a little bend. That's straight enough. I mean, I could draw a little bend there and a little bend here. Not perfect, kind of going farther over than I need because I need more space. But it doesn't have to be perfect, so I drew too perfect of a one. Sure. That has a little bit of a bend right there. It's got a little bend, not perfect. It's straight enough. It's not called the perfectly straight condition, but there we go. And Brenna, I agree. Now, not straight enough might look something like this. Now, let's ask a really big question right here. The correlation on this, I'm going to do it even better. The correlation on this graphic is going to be close to what? What will the correlation on this graphic be very close to? The correlation on the bottom graphic will be very close to what? what will the correlation on the bottom graphic be close to? Straight enough means that a straight line well approximates it, Heidi. Great question. So it's going to be close to 0. So when you plot the line through here, the correlation or the linear regression doesn't do a good job with it. And so this is where we meet it. And this one would not meet it down below because it's categorical. You can't even do the remaining conditions on that because it doesn't meet it. So we're drawing the red pen to show where it doesn't meet it and the green pen to show where it meets it. QQ is met because both variables are quantitative, so I circled the x and the y are quantitative variables. I would say x and y are both quantitative variables. Now, the bottom graphic I just drew, is there a relationship between x and y in that graphic? Is there a relationship between x and y in the bottom graphic? Is there a relationship? Is there some sort of relationship at all? And the answer is most definitely yes. Correlation of 0 does not mean two variables are not related. It means with Pearson correlation, which we do in this class, it means there's no linear correlation. There's no linear association. So there's a parabolic relationship to this that we can clearly see, some sort of parabolic equation, but it's not linear. It's a strong nonlinear. Julio's right there. So the form is nonlinear. It's still strong from the vertical scatter. It's actually stronger than the top one. The top one is actually weaker than the bottom one, but the top one has a higher correlation because correlation measures linear strength. So QQ, straight enough, no outliers. When we talk about no outliers, we don't want to see outliers. And I like to say no outliers because outliers are bad. Now, I will say this. We try to make the outliers as clear as possible. On the test or something, I really like to make my outlier something like this right here. You know what I'm going to do on the test? I'm probably going to circle that outlier and be like, oh my gosh, look at that outlier. That outlier is way out of control. So we got QQ straight enough, no outliers. The reason I say no outliers is because I want to say we pass the condition of no outliers. To pass the condition of no outliers, there should be no outliers. So we'll draw a nice perfect one up here. And it can have, yeah, sure, whatever. I mean, this doesn't really have any big outliers. Every residual plot will look, or every plot will look a little bit different, but there should be no outliers. I mean, even that, it's probably not a big thing. Look for the bad ones that get away from you. We really don't have any big outliers. We really don't have anything that's extreme, and look for the extreme things. I'm putting a little like worse ones, but look for the extreme. That's probably the best tip I can give, because if there's an outlier, we want to try to highlight it. QQ straight enough, no outliers. Plot does not thicken. Plot does not thicken is going to go right here, and hopefully, yep, got enough space, just barely. When we talk about plot does not thicken, what are we talking about? That plot does not thicken condition means that the plot itself does not get any thicker or thinner. So one example I like to use right here is I like to say, what if it got thinner? What if the plot right here got thinner? So when you look at this right here, it's actually getting thinner. Does that pass or fail? Well, hint, it's on the bottom. So we're going to draw some bands around it to show where it has the problem. The bands around it being this right here are showing that there's a problem. We have a change in strength that fails. Nice job in the chat. And if you notice right here, we kind of have a constant strength to this. Now, it doesn't need to be perfect. I'm drawing some like really good examples that show you what's going on, where this is going to get like really strong here at the end, and the plot got thicker at a different part. So when we say, does this apply to residual plots? And it does also apply to residual plots. So anything we draw here could also be made into a residual plot. So all you'd have to do to turn any of these into a residual plot is take the line and make it flat. So I'm going to draw a little example below this, because I could make a residual plot of this. The line would be flat, and then the points would be here, and you would still see that huge outlier down here. If I were to turn this one into a residual plot, it would have this, and then it would have the points all like this, and then they'd get closer as they went on. So there'd be this huge scatter at the start. So how do we turn a regression into a residual plot? You take the line and you make it flat. So if you think about this one up here, I'll draw a residual plot of it up here. You'd make that line flat, the line being what goes through the middle of it right here. Can't draw a line through the middle of it. But you would just take that line and make it flat. And then if you notice, look at this residual plot I'm drawing right here. The residual plot is the line flat. So does everyone remember the question we just did? Look at that top residual plot, and let's go back and take a look at the thing. I'm going to have to go back to lecture, and then we'll hop back right into this. Let's go here. Then let's go. And let's go back to the desktop. Remember that good residual plot I just drew? Does that good residual plot look a lot like that graphic there. This is a good residual plot. This residual plot shows no pattern, and it's just the line flat. So it's just, if you took your line and made it flat, it'd be the residual plot. And so this is a very good residual plot. It shows really no pattern. You don't want to see anything in a residual plot because 0 is where the line is at. Does that make sense on this? What a residual plot is? You take the line and you make it flat, and that makes it a residual plot. And then the distance above or below is what the residual is. Does that help out? Or people got some good advice on that? We're almost done with the Kahoot. And thank you, everybody. Yes, awesome. I like seeing that in the chat. So great questions. We're always here to answer it. We got like 2 or 3 more questions. 3 more questions. What percentage of track runs are expected to run at a time of 290 or higher? Oh my gosh. So 290 is going to be a z-score of what? 290 is a z-score of what? Go ahead and plot on the z-score. It's a z-score of what? 290 is a z-score of, you might be right. You might be right. 290 is a z-score of -2. So when you do 95 between that, we should know 95 between, that leaves 5% outside. And then above -2, if 2.5 is below it, would be in 3, 2, 1, right next to me right here. There it is. The green answer is correct. This is practice on the empirical rule. It's time for our last real question. The last one's a fun one. So let's go here to the quiz. 68, 95. You should know these numbers pretty quick. 68, 95, 90 something. I don't know what the number is. You have to help me out. I've forgotten the empirical numbers. I do not know. Help Brian. No one get this wrong. 68, 95. What is the last number on the empirical rule quiz right here? 68, 95. And the last number will be. What will it be? 68, 95. Purple. Lucas, 10,000 points. Lucas right there. 99.7. You know, I said that's the last question, but there's one more awesome one. If you are in the lead, I encourage you to respond quickly to this question because there might be no wrong answers. Hint, hint, hint. But we got to know from everybody, what is the best superhero? What is the best superhero out there? Does anyone have any idea who the best superhero is? We got the choice between Iron Man, Wonder Woman, Batman, Spider-Man. We got a little, what is his name right now? I can't think. Not Andrew Garfield anymore. Why can't I think of his name? He's doing a really good job as Spider-Man. Tom Holland, that's his name. Tom Holland, Gal Gadot, Robert Downey Jr. Miss him so much. And then we got I'm trying to think of all the Batman's names that have been. So we got George Clooney. We got all these things. Well, not anymore after the Cap's a great guy too. So who? Star-Lord. Star-Lord is awesome. I was actually thinking about that. Robert Patterson. You're welcome. Total shout out to you there, Lucas. Wrong, it's Thor. Thor is awesome. Oh, no, don't worry. This was just for fun. And remember all the learning objectives. New exam 1 podium is, I think that's going to be, wait, what? Oh, that's the third. I was like, who? I was like, Charmin Dog. Oh, this is like a new thing right here. This is like super cool. What was he going to show? Flying Bat. Oh, they really. So you guys are awesome. Runner. Oh, this shows the runner up. Well, we couldn't really see. Great job on this. Excellent work. So we're going to do some more reviews. We're going to do more practice. But we had people leaving throughout this. Ended at 11th. Sad day. I guess people were losing. But does anyone get first, second, or third in the chat? We might have, if no one ever claims first, second, third, we might have some people getting the Starbucks gift cards who are in 4th or 5th. But take a screenshot of it. Did anyone get first, second, third in the chat? No, that's all right. Third, nice job. $5 Starbucks gift card. I'll probably be picking them up over the weekend. Solid 49th place. I'm Flying Bat. Nice. Amazing work. Great job. Awesome. Great job there. Amazing. Good catch. Like it. Nice job. So we will end class right now. Thank you so much, everyone, for being here. Remember, we're going to do more reviews. I'm probably going to be cutting up some of those speedrun videos. And if you have questions, you can always email me at bstevens@utk.edu. Charming Dog, amazing to have you. And you're welcome, everybody. Let's end class. I'm just going to go back to my office again right now. So just give me a moment. I'm going to go to my office and just get some stuff here. So I'll be back here in just a moment.
Hey Brian, what's up?
Hey, Adam.
Oh, what's this?
Adam, what are you doing? Adam.
No!